Today we are going to see another problem in electrostatics. Let us get into the problem directly. So the problem given that due to a point charge, potential electric field at a point A are given as 7 volt and 3 volt per meter. So potential is 7 volt and field is 3 volt per meter respectively. And the electric field at a point B is less than 3 volt per meter. They didn't say it specifically, but they mentioned that it is less than 3 volt per meter. Now magnitude of the charge is triple. If the electric field at B becomes 3 volt per meter, what is going to be the potential at that point? So the options are given as 7 volt and 7 volt and 12 volt and 21 volt and data insufficient. These are the four answers which they have mentioned. So let us see now what might be the suitable answer for it. Before going to the solution, we need to understand here. So due to one particular point charge, they have given the potential field at a particular point, and at another point they mentioned the condition for potential. They didn't give exact value of potential, and they didn't mention what is going to be electric field in the initial condition. But in the later condition, when the charge is tripled, they mentioned at point B what is going to be the electric field, and now they are asking you what is going to be potential at that point. Let us try to solve this. So for solving this, let us consider first the diagram. So diagram initially, when Q charge is given here, let us consider point A is at R1 distance and point B is at R2 distance, somewhere here. Now here EA initially, which is given as 3 volt per meter, VA which is given as 7 volt. Now when the charge is replaced with 3Q at this point, here they mention that EA dash which is equal to 3 volt per meter. Okay, this is what the given information here. EA initial, in the initial condition, EA is less than 3 volt per meter. This is the given information. So first let us try to write what is given exactly one by one here. So in the initial condition, if charge is Q, the equations mentioned are EA is equal to 3 volt per meter. So basically this is going to be like KQ by R1 square, which is equal to 3 volt per meter. Now VA, which is equal to 7 volt they have given. This implies KQ by R1, which is given as 7 volt. Okay, so when charges, if charge is 3Q, when the charge is tripled, they mentioned that EB dash which is equal to 3 volt per meter. This implies KQ by R2 square, which is given as 3 volt per meter. Now from these conditions, in the initial condition VB dash EB also given, which is inequality like 3 volt per meter, less than 3 volt per meter they have given. Now to solve the problem, let us try to find out what is, they are asking you what is VB dash. What does it mean, like KQ? So it is like here also, pardon, 3Q. So 3Q by R2 is equal to what? This is what they're asking you. So now from 1 and 2, if I find R1 R2 relation, then I can substitute into this equation. So let us take EA by EA and EB if you try to equate. So as you know, EA and EB dash are 3 volt per meter. So equate those two first. So KQ divided by R1 square, which is equal to 3KQ divided by R2 square. So if you directly cancel KQ, and you can be able to see that R2 is equal to root 3 R1. Okay, we got R1 and R2 relation. If you substitute VB dash, which is equal to 3KQ divided by R2 value, I'm going to write root 3 R1. Now this will become like root 3 of KQ divided by R1, which is 7 volt. So root 3 into 7 volt. So VB dash, which is equal to root 3 into 7, which is exactly equal to 12.12 volt, which is 12 volt approximately, because they asked you nearly, so nearly it is going to be 12 volt. Thank you. We'll meet with one more video, or one more problem in the next video.